Don't mind the dogs.
It's all good.
Okay. All right. So it is a homework or group meeting quiz. Sorry. Okay. So I got number 3 wrong, 13 wrong, 16, 17, and 18 wrong. But the rest I got right.
Well, that's good.
Yeah. What about you guys? How did you guys do?
I did not do it first, so I am in the middle of it right now.
Well, so question 3, I see that answer is 1. Is that what you had?
No, I had 4. Is it 1?
Yeah, I would say it's 1.
Oh, okay.
Back to the outline book on the book.
Uh-huh.
I went back and I'm going back and scrolling back through it. It says, I'm gonna find it and read it. Under the density curve section, normal density, under this paragraph here. And it says all density curves, including normal density curves, have 2 basic properties. 1, the total area under the curve equals 1.
Oh, okay. I don't know why I had 4. It's a blonde moment.
And also there leads us to the, I believe it's the next question then on the quiz. Because it says the density curve always lies on or above the horizontal axis. So
that's false.
Yeah, so that means 4 is false.
Yeah, and then 5 is true.
Yep. And then for 6, I got A.
Really, I got C.
Did you get that? You got that one right, though, right?
I did. I got C, and then 7's actually A.
That is weird. What?
So
Yeah.
7 is A?
7 is A, and 6 is C.
Because if you open up I opened up the link to that normal probability applet.
Yeah.
The score was -1, and so I figured that. But you got it right, so can't argue with that.
So which of the 7? Let me understand this. Which of the following elements of the figure represents the probability that the Z score will be greater than 1,000? So you have to look at both the middle section and
the outside of the lines too. So if you look at it, the shading what's blue, that would be larger than what's not shaded.
That doesn't make sense though, because doesn't that dip into the negatives?
Yeah, but you'd still have a greater negative than you would a positive.
Oh, okay, cool.
That's how I understood it. I could be explaining it totally wrong, so don't quote me.
So which of the represents the probability that the Z-score will be greater than 1? Okay.
Do you want me to? I can do a screen share. Does that help?
Okay.
Oh, okay. Okay. So I'll scroll back up. Okay, so obviously 1 and 2 are true. 3 is 1. 4 is false. 5 is true. 6 is C. 7 is A. Are you guys on 8 yet?
Yes, I am.
I'm looking at 8. I'm still.
Okay, so I got 68 for A. What did you get?
No, wait. What percentage of the data of the bell-shaped distribution? That's when we had to do the calculation, right? Let me see.
Well, all right. So for me, it was just as simple as Googling what is the, or even just reading what is the 68, 95, 99.7 rule, and it says right in the text that says that 68% of all values fall within one standard deviation of the mean. That's just 1/3 of the rule.
Yeah.
So what did you say the answer is there?
68.
Because it's part of the 68, 95, 99.7% rule.
Yep.
Yeah.
And then 9, I have 0.683.
Oh wait, so I plugged. Okay, so I'm different. It's because I pulled up my that normal probability applet, and don't we plug it in at the bottom there? Let's see.
Yeah, so where like the negative ones would be.
Yeah, unless I did it wrong because I went -1.
Here.
And then mine comes up. Okay, I'll look on your screen, but see, because mine came up 0.3173.
So, okay, so you can see my screen, right?
Yeah, I can. I did there. Yeah.
Okay, so you're looking for the in between -1 to 1. So if you highlight just in between here, you're going to get 0.6827, and you have to round to your third one. So it changed to 0.683.
Oh, that's what I did wrong. Okay. I see that now. I was looking at it wrong.
No problem. Yeah, you can just like click on them and it'll actually do it for you, and it'll tell you like what the area is, if like the blue shaded and what it's not.
So 6.8. Yeah, I see that on mine. On even as I plugged it into mine.
Yeah.
0.683.
Yep.
I'll correct mine now. 6.683. All right, then let me. I just want. So I'm gonna go back before we say anything out loud. Let me go back and I'm gonna plug into the -0.2. Then mine comes up. Oh wait, that's still the one. Whoops, wait, let me get it. -0.2. All right, so then that came up 0.1585, which will be rounded 0.159. Is that what you got?
No, I have 0.955.
Oh wait, but point. Maybe I'm plugging it, but it'll be negative.
So on your app.
I plugged it in wrong. I plugged it in.
Oh, okay. Well, I'm glad you're figuring it out. It's better to like realize how to work it than not to.
Yeah, definitely.
So just -2, correct?
Yeah. So if you want, if you drag the red, so you have it at 1, you can just drag the red lines to -2, and then you'll find out what it is, and your area will already be shaded for you.
0.955.
Yep. And then if we drag it to 3, if I can get it.
You got 0.997, right?
Yeah.
Cool.
Yep. And then 12 is the values of the values matching the 6, 8, 9, 5, or 95, 99.7 rule.
Yep.
Say that. So what was it?
So the values match the 68, 95, 99.7 rule.
Okay.
Because if you look at the numbers, they all match. They're identical. So I got 13 wrong. I have 0.762, and that's not the right answer.
Let's see.
All right, let me see. Let me get here. Okay. So, so this is probably that proportional problem. Let me go back and look at this. So, because I was working with that. So we do where you take let's see, subtract the mean, and then you divide it, and then, let's see, you take, like in their example, they were saying you take the height of Sarah's height, divide it, or subtract the mean, and then divide it by the standard deviation. So it's probably something like that. In the quiz. So we have the population mean is 0.65 and the population standard deviation is 0.07. So if we went, let me see here. So we did 0.60 for question 13, 0.60 minus what was listed as the mean above, 0.65, and then that answer divided by that deviation of 0.07 would give it negative 0.714.
Negative 7.14.
I see. Yeah, point zero. Yeah, negative 0.17. Oh, I'm sorry. I'm looking at my calculator wrong. So negative 0.714.
Oh.
0.714. 0.714.
And then do we have to put that into negative?
Yeah, you have to show it as a negative.
Okay, so negative. Okay. So at least now I feel better now how to do it.
So then on 14, let's see. What proportion of the population of protein that is more than 0.60? Wait. What proportion of the population have a protein requirement that is less than 60? So this looks like then we would, I think we would add there. If I did that. Let me go back and look on that. Well, what do you, let me look at that, I think. Let me look over up there.
So I got 14 right.
Oh, you got 14 right? So let me see what I get as an answer there then before.
Okay.
So if I go, so let me see. So if we did 0.60 plus the mean, if I'm doing that right, plus the mean, which is 0.65, divided by the deviation 0.07 equals to be, is that correct? Then 17.857, is that right or wrong?
I have 0.238.
So then I'm doing that wrong. I calculated that wrong.
Brandon, what do you get?
Yeah, how did you get that answer, Hillary?
So I kind of just went with like the formula that they gave.
Which is what the same formula that we used in 13, right?
Yeah.
So but because the one in 13 talks about less than, but the one in 14 talks about more than. So how do we change that around?
Here, let me write it out really quick again.
Yeah, let me see if I can wrap my head around this.
Where'd it go? If I could find my notes, that'd be great.
And what did you say you got for correct on 14?
I got 0.238.
Oh no, see, I still didn't get that.
Because I know it has to go with, like, once we find it, we, like, plug it in into the z-score. One second. Okay, so the formula to find z-score is z equals x minus m divided by the one that has a squiggly line on it.
Yeah, which is the standard deviation. And that's
Yeah.
how we got 13. That's how they answered. That's how I answered on 13. But that spoke about less than, so
Yeah.
um
I lost my quiz too. What the heck? My computer doesn't like me today. Sorry, 1 second. Logging back into everything.
It logged you all out of everything?
Yeah, like my quiz and iLearn and
so
Wow.
is your did you get 15 right?
I got 15 right. I got 0.762. But I didn't get negatives for those. I got positives. Like I put them in as a positive and they were fine. So if I'm going to open up the applet.
And you said on 15 you got positive 0.71.
762. Okay, well, back to the quiz we go. Okay.
What am I doing?
-6. Okay, so So on the applet and the area, is that where we plug in our number, or do we put it in at the z-score?
I think, well, let me open it up. Okay. We're on 13, right?
Yep.
Or no, sorry, 15.
Then 14 would be.
Okay, cool. So the z-score is that.
Because we're finding the z-score, aren't we?
Yeah, and the z-score is just the so in the case of question 15, it would be 0.7 plus the mean
Which is
divided by the standard deviation. So 0.7 or yes, 0.7 plus, because if you're looking for greater than, it's subtracted.
and then if we're less than, we're adding, right?
That's what I'm guessing. Yeah. So 0.7 plus 0.65 equals 1.35, and then divided by the standard deviation, which is 0.07. Your z-score, I don't know if this is right, but the z-score I got would be 19.285.
We're doing something wrong.
I'm going to plug that in. Less than 0.7. Don't remember how you got that answer at all?
No. I know I was messing around, and I was just kind of like, well, I'm just going to plug these numbers in and try this. And then it worked. And I just submitted it on a whim because the rest of the quiz I got wrong. So, oh, jeez. I've gotten closer to our answer, but I'm doing something wrong. So, in the normal probability applet, if you shade just the blue to the right before the red line, I get 0.0274. So,
what's your z-score and what's your area on your applet?
So my z-score is 0.6. So here, let me try this. Let me put the area in as what I have, 0.238. Okay, so our z-score should be 0.713.
This is on.
There we go.
Okay, so if we put 713 as our z-score,
that works.
It should be easier to fill out the formula, right?
How did you get that? Yeah, if you plug that in as the z-score, you get the correct answer in the applet.
Yeah. So
how did you find that z-score?
What was that z-score?
So I just typed it in the area, like the answer that I got. I typed that number up in the area, and I got the z-score.
Okay, gotcha.
And what was the area?
The area is 0.2388, which is the answer. See, I told you, like, I was literally just playing around with the stuff, and I was hoping I was getting the right answers. Like, don't quote me. I'm really bad at statistics. So that gives us our z-score.
So the z-score is 0.304?
No, so the z-score is 0.713, but the answer is 0.238.
Oh, I'm still missing something there. So you put in what area did you put in there?
0.238.
Oh, okay. And that's how you got the 0.713 z-score.
Yeah.
And where did we get the area 0.2380?
On the applet, or what do you mean?
Oh, I understand everything now.
How did you know to put the area, that area amount there?
Okay, guys, you ready for this? Here's how you get the answer. I just found it.
Okay.
So we had the right formula about 5 minutes ago, but we added when we should have subtracted. So you take the 0.7 and you subtract from it the mean, 0.65. Then you divide that by the standard deviation, which is 0.07. Then from that, you get 0.714. That is your answer. Then you stick that into the z-score, and in the area, it pops out with the answer.
Okay, so let's go back and do that for 13 then. So, okay, so
13 would be 0.6 minus 0.65, and then divided by 0.07, we get that number, which is negative, the same z-score as before, just negative. That's weird. Okay, so then, and the question was less than 0.6. So it should be.
So, and we just shade over
0.762, which is weird because that's the answer to 15.
You said that's for 13? You figured out so again, you went with 0.60 minus 0.65, which is the mean, divided by the 0.07, and then you took that answer and put it into the applet.
Correct. I put it into the z-score area.
So I have a question for you for 13.
Yeah.
Because my original answer was 0.762.
Was it?
Yeah. And it said I was wrong. So are we not supposed to count in the middle?
We should, because it says less than 0.6, and 0.6 is not a negative number, so you have to go.
Right.
Right? But if you got it wrong, then clearly that's not the right answer.
Well, I'm okay. I'll submit it, and then we can go from there. How about that?
What do you mean?
So, like, we'll keep working through, and then we'll keep that as the answer, and then I'll submit it, and if it's wrong, then you guys still have another chance to go back and fix it.
Oh,
because if you go back and look at that booklet in the outline, under the normal, and it gives you the example of using the normal probability applet, and it says type in the z-score of 2.041 into one of the two boxes along the horizontal axis of the graph, and then click the areas under the curve until only the areas left of the z-score are shaded blue. The total shaded blue under the normal distribution, and it gives you the graph. And so that's showing that this is the portion of the young Ghanaian women who are shorter than Surwa. So that's because you're looking at the center plus the left-hand side is how you're getting the total area. Maybe it's more than just the center that we need to plug in. We need to look at, because see, if you take in from that z-score of 0.713 and you take in both the center and the right side, now we're giving an area of 0.7621. Or have I just confused the matter?
Well, 0.7621, Hillary, that was your first answer that you got wrong, right?
Right.
Okay.
So
Because
really
that's the
confusing.
same one as for 15.
Sure.
But 15 was wrong, or 15's right?
Which is weird. No, 15 she got right with 0.76.
See, so here's what confuses me, because on 13, the 3.7.13. Oh, once that goes through, what am I? It's just to the right. It's not in the middle. But 15 has the middle and the left side. Does that make sense?
Yes.
So now I'm wondering if maybe 13 is just the left side, which is...
So that would be 0.238.
Oh, what am I doing?
Is that what you're saying?
Yeah, but I just messed up my probability. I put so 1 second. Sorry.
That's the answer to question 14. 0.238.
Right.
No, I thought you just said that was the answer to. So only the left side itself is the answer to 13. I thought she just said.
Right, but that would make it be the same towards the right side too. Wait, well. I feel like we're missing something. Unless it is. Okay, so go ahead.
No, sorry. I was just going to say, what if we move on to the next questions and then we'll knock those out and then.
Okay, yeah.
Because it is just one question. So if we want to get 17 out of 18 right, I'm cool with that.
So am I. Okay, so I'm completely lost. 16 down.
16 down?
Yeah, I have no idea. Like, I'm completely lost. So 16 is another probability one.
So, well, so again, this is taking us to where we're finding the probability of the two values, and in that section there, let me. Find the z-score for both values. And then it looks like we find the z-score for both values. and then subtract the smaller from the larger. So 16 let's say if we find the z-score for .6 minus 0.65 divided by 0.07 is again that negative 0.14, but then what is 0.7 minus 0.65? They're the same both sides. I don't know.
Okay, so I'm at a loss. What about you, Brandon? Any?
Nope, not really. Trying to figure it out here, but not getting anywhere.
Remember that to find the area between the two values, shade to the left of each z-score you calculate, and then subtract the smaller area from the larger area. If your answer is positive, make sure your answer is positive.
Okay, I think I'm on to something here. So we're on 16, right? Yes. Okay. So 0.6 minus 0.65 is that.
Does this video have to be uploaded by 11 o'clock?
Yes.
And our quiz has to be submitted by 11 o'clock too, doesn't it?
Yes.
No rush, right, guys?
Yeah.
Right?
No rush.
We got some time. I'm so. Boy.
Do we each want to like tackle a problem and go from there?
Yeah.
I'll take 16 because I'm really close. I feel it.
Okay, I will take 17.
All right, I'm going 18 then.
All right. Wait, to do 17 and 18, don't we have to have 16?
Ah, crap.
because otherwise we can't do anything. But I'm going to look up what the 35th percentile is. So, oh, wait, what was that? All right.
Yeah, I got it.
Okay.
So, all I did was find the z-score of both 0.6 and 0.7, which is negative 0.714 and positive 7.14, respectively. And then I just plugged it into the applet, and I got the answer, 0.525, which means that
35th percentile. Don't we? Now it's like on the thing. I just gotta. So, 50th percentile would be 0. I just don't know how to find the percentile. That's where I get. Okay, isn't it the percentile rank formula is R equals P divided by 100 and then N plus 1?
R equals P divided by 100 plus 1.
No, okay, so R equals P divided by 100 and then in parentheses N plus 1.
Might be. What are those variables stand for?
I will let you know in just a second. I'm asking Google. Oh.
Okay, so from the thing it says, from our outline paper, it says to find, like, first, if we find the z-score that corresponds to the 90th percentile, using that applet, we type the desired area or percentile in the box at the top of the graph. For example, the 90th percentile would be entered as 0.900. And the z-scores corresponding to this area will be displayed in the bottom right box. So when I plugged in 0.90th for the z-score came out 0.282. So I'm going to try the reverse, and if I do the 80th according to that as our booklet there suggests, it's saying that the z-score for the 80th percentile then is 0.842.
0.842?
Yes, for the 80th percentile.
So for the 35th, wouldn't it be? So do we? I'm still confused.
So according to this booklet, then it would be, you would put 0.350.
Up in the area or below?
Yeah, in the area. Yeah, up in the area. 0.350. And gives us a z-score of 0.385. No, wait, no, 0.3. Wait, Meg did it wrong. Wait. Oh, what was the percentile you're looking for?
The 35th.
Yeah, so 0.350 is 0.350. Enter.
Oh.
And it's giving a z-score of 0.385. According to the applet.
Let's see, because I'm totally confused on the 35th and the 80th percentile. Because I know you're supposed to be able to do it on the normal probability applet. Wait. I think I'm onto something. Oh, maybe not. So, at the z-score on the bottom, do we have to shade anything in?
Well, from the booklet, I'm seeing that it is just normally shaded in.
So is it just the middle one, or do we have to actually shade? Because if we have to actually shade, then it changes.
Well, let's see. It has didn't have the middle shade.
I'm gonna end the live broadcast, so that way it has enough time to load.